All right, in this video we're going to continue with some more terminology that's important to understand before we start talking about specific functioning of the neuron. So if we are looking at our neuron and we're looking at the voltage of that neuron, we can measure that. So we can put a voltmeter into the neuron. And we can measure the voltage, which remember is the amount of difference in the electrical charge between these two areas. And we can get a actual value or number. So when we have a neuron, let's assume it's this one, and let's say that it's at rest, which just means that it's not communicating or sending a nerve impulse at this time, we have a kind of standard standard voltage across this plasma membrane, and it's -70. So we're going to go to our, so I have created a graph, and I think the graph kind of helps understand these terms a little bit better. So the graph that I created, it has, these are in millivolts. So these are all millivolts measuring, and this is over time. So if we are to look at a neuron that is at rest, meaning that it's not sending a nerve impulse, that difference in the charge, that voltage across the plasma membrane of that neuron at rest is typically -70 millivolts. So again, we can like put a little voltmeter in here, stick the end just inside the plasma membrane of this neuron, and it would read -70 millivolts. So there's that much difference in the charge between these two areas. And it's negatively charged because we're measuring the inside of the neuron. So we get a negative charge. So I'm going to draw, use blue here. So I'm going to draw the charge, or the voltage of a neuron at rest. Sorry, my hand's a little shaky. So this is the voltage across the plasma membrane of a neuron that's at rest. Okay, so we're going to go back to our picture. So we know that this is -70. We'll say this neuron's at rest. So this is -70 millivolts. That's the voltage. And that's the difference in the electrical charge across the plasma membrane. So we call this state of the neuron at rest, or we call this, we have a term that we use to describe this difference in the charges, and we call it polarized. So polarized, we'll put that on here. So we use this term polarized when we're talking about, let's see if I can get this to closer to that. We call it polarized, and the reason we call it polarized is because they're very different. This area is very different in charge versus this area. So they're like kind of polar opposites. So that's where they get that term polarized. So we say this plasma membrane is polarized. Okay, so if we go back to our graph here, so this is considered polarized. So if we have some sort of change in our in this voltage or difference in the electrical charges across the plasma membrane, so let's say we have a change where we start to get the -70 millivolts difference across that plasma membrane, and it starts going, realize up here is 0, and then we have the positive charges. So if we start getting this change in this polarized state of -60 millivolts of a resting neuron, if it starts going less, or I guess you could say more positive, so this is going towards positive or towards 0, then we will say that it's becoming more, like here would be where both sides of that plasma membrane have equal numbers of charged particles. So this would be where they're not polarized. So if we're moving in that direction towards not being polarized, they will use the term for that change and they'll call it depolarization. Oh, sorry. Depolarization. I just need to slide this out a little farther. So they'll call that depolarization. So anytime this polarized state of negative 70 millivolts starts moving towards something that's less polarized, so usually it's moving towards 0, that's usually what we'll say. So we'll say that if we have a movement of voltage towards 0 or more positive, sometimes we'll use that term too. That's the term. We'll just, instead of saying all that, we'll just, oops, we'll say that it's depolarized, being depolarized, or its depolarization is happening. Okay, so now we could have an instance where we're going to start down here, where all of a sudden we're at the polarized state, and then all of a sudden we have a change in that voltage where we start moving and becoming even more polarized. So we're getting even more away from being the same on either side. Voltage is the same on either side of that plasma membrane. So if we start having that change where we're moving away from, or we're moving more polarized, we call it hyperpolarization. So hyperpolarization. I'll have to spread my box out a little bit here first. Yeah. So a movement of voltage away from 0 or more negative would be the other term for that. That's the term that we'll use when we start getting that difference in the charges across that plasma membrane even being more different, so more polarized. So we call that hyperpolarization. And then realize that these changes in this negative 70 millivolts across that plasma membrane, they can happen, and then they can also reverse. So if we do get a change in the voltage across that plasma membrane, and we start to depolarize, it could go like, even up to the positive, we can have changes where then it can start to go back down. We'll try to go between here, so back down towards that negative 70, and so the term they use for movement back towards polarization is called repolarization. It's kind of like the opposite of, so movement, oops, back towards the negative 70 millivolts. So if we start moving in that direction, going this way. So we will talk more about these terms and apply it to neurophysiology later, but hopefully that explained it a little bit, so you kind of understand how we're describing the changes in the voltage across the plasma membrane of a neuron. So I will see you guys in the next video.